Okay, these are free response questions, practice free response questions. This one is without a calculator, so we will not use a calculator. This question says a car is traveling on a straight road for 0 to 24 seconds. The car's velocity, v of t in meters per second, so that's my unit, is modeled by the piecewise linear function defined by the graph below. So that graph is v of t. V of t means every y value is my slope. Now let's see, for what intervals means all the x values of time, does the car have zero acceleration? Acceleration is equal 0, which means in this case, if I'm looking for acceleration using this graph, that graph is v of t, so I have to draw tangent lines to get the second derivative, or because the velocity, this is my first derivative, so to get the second derivative I have to draw tangent lines. So they said where the acceleration is 0, and you can clearly see it where acceleration is 0. If I draw tangent lines here, it's positive. When I draw a tangent line here, these are negative. But when I draw tangent lines over here, that's all 0. It's a horizontal. So from 4 to 16, I have acceleration 0. So that's part A. Part A said acceleration is equal 0 when the graph of v of t, is constant. Like it doesn't change direction, it just go in the same speed. And doesn't change direction, it's not increasing, decreasing, and you guys can tell it's going in this in the same speed like the car. So it's a constant which occurs at on the interval 4 to 16. So that's my part A. Let's do part B. Part B said for each value of v prime 4 and v prime 20, find the value or explain why it does not exist. Indicate units and why it does not exist, like explanation, justification. First we have to do v prime 4, which means acceleration at 4. This is acceleration at 20. These are the 2 points. So this is 4 right there. That's a 4. And if I draw tangent lines, I cannot draw tangent lines here because let me erase everything and I'm going to show you clearly. At 4, when I draw tangent lines, first of all, I'm going to get a lot of tangent lines here, not more than 1, which means, and it has a cusp, so it's not differentiable either. Like it's undefined, not differentiable. It's a cusp, so that's the easiest way to think. So I'm going to say v prime 4 does not exist, okay, why would I spell this does wrong? Does not exist because the graph of v of t has a cusp. At t equal 4. So it's not differentiable. That's one thing. Now let's figure it out. What is v prime 20? So 20 is right here. When I draw a line, I have this is 20. And when I draw tangent line, it's negative, but you can tell the tangent line in this v of t line is exactly the tangent slope of the line, and this one is exactly should be the same because they are parallel lines. So I'm gonna go v prime 20 is equal, and how do I, if they are parallel, I can pick this point and I can pick that point, like 24, 0, and I can pick 16 and 20. Why? Because the lines are parallel. So if I get the slope of this, and that would be the same slope at the tangent slope, the one we just drew. Now you guys also pay attention here. If I pick, you know that it's a linear line. So if I pick this point, that point, draw a tangent line, you know the graph, the slope is going to be same. Any point you pick, the slope is going to be the same. So I'm going to go v prime 20. I'm going to pick v of what is it, v of 16 and v of 24. So I'm gonna get v of 16 minus v of 24, which is 16 subtract 24. So what is v of 16? 20. What is v of 24? 0. And this will give me negative 8. Solve this. It's going to be negative 5 over 2 meters per second square. So this is my v prime 20. Now, part C, it says, let acceleration a of t be the course acceleration at time t meter per second for 0 to 24. Write a piecewise defined function for a of t. They said, right. Like all I have to do is make a piecewise function equation. Like what is the acceleration at every piece? So I'm going to erase all of that again and we will see how it goes. So I'm going to go for part C. Here is part C. Acceleration I'm looking for every piece, which means acceleration means a tangent line slope I'm looking for every piece. For this piece, just for this piece, if I draw a tangent line, it's going to be positive. So I can say I'm rising and running because you know it's a positive slope. So how many times I'm rising? I'm rising 20, and how many times I'm running 4. So 20 over 4 means when we simplify 20 over 4, it's going to give me 5. So this one is 5. What are the restrictions? Restriction is 0 to 4. Next one. When I pick this one, this piece of the information, I know the tangent line over here is 0, so I don't have to do anything there. So this tangent line or the acceleration here is 0 and the restriction is between 4 and 16. Next one. This piece of the information right there. What is the, we already found the tangent line for that one in the part B, which is negative 5 over 2. So I don't have to do this again. I'm just going to write negative 5 over 2. What are the restrictions? 16 to 24. So this is part C done. Next one, part D. They said find the average rate of change. Find the average, which means secant, rate of change of v, which means I'm looking for technically acceleration. I'm looking for the secant slope of velocity, average between of the interval 8 and 20. So I'm going to solve this part first and then we're going to go for the mean value theorem. So let's try. This is part D. I said average rate of change is equal, since I'm looking for average rate of change of a velocity, you know this off part is very important. This one, off velocity, that's how our formula is supposed to be. Like I'm gonna have a v here. So since I'm talking about 8 and 20, so that's what I'm doing. V of 8 minus V of 20 over 8 minus 20. So when I do this, I know V of 8 is 20. And I'm just looking for the y values because I know this is a velocity graph and every y is a slope anyway. So when I see V8, the V8 y value is 20. So that's 20 equal 20. V of 20 is actually 10. 8 minus 20 is going to give me negative 12. The answer is negative 5 over 6 and it's meter per second square. So that's my average rate of change. We got that part. Does the mean value theorem guarantee a value of C for 8 to 20 such that V prime C is equal to this average rate of change? This is average rate of change. So we know mean value theorem. According to mean value theorem, the function has to be continuous and differentiable, and then we apply the formula, and the formula is going to be V prime C equal negative 5 over 6 because that was the secant slope or the average rate of change. So the function is continuous everywhere. Is it differentiable? That's another thing. So you guys can the values they're telling me 8 to 20. So this is 8 right there. This is 8, and I'm talking about everything till 20. 8 to 20 is not differentiable at this part because it's a cusp. Why? Because you're gonna say, okay, why they have a 16 and 20 there? This 20 is the tangent slope, right? At 16, because you know every y value for this v of t is going to be a slope. So this is a y value and it's 20. This is a 20 is the slope for 16. But the question is asking average rate of change of v, which means I'm looking for acceleration. I'm taking a derivative of this, which means I'm drawing a tangent lines on each piece from 8 to 20. So I can draw a tangent line here, that's 0, tangent line here, that's negative, but up here, that's a cusp, so it's not differentiable. So when it's not differentiable, I know it's a continuous, but it's not differentiable, then the mean value theorem is not applicable. And the mean value theorem does not guarantee a value of C between 8 and 20. So that's what we are going to explain. I'm going to say mean value theorem is not does not or is not guarantee the value of C between 8 and 20 because V of t graph is not differentiable. There you go. Is not differentiable. So we are good. Like we cannot find V prime like such that I can have to use that such that V prime C is equal -5/6. Tangent slope is equal secant slope. So that's for this question. This is the third question. A particle moves along the x-axis so that its position at any time t greater or equals 0 is given by the function. That's my original, like a position. P is measured in feet and t is measured in seconds. Find the average. Average means a secant slope. Average means secant slope, and velocity, that's the first derivative, so actually we are looking for the secant slope, and the interval t equal 1 t equal 2 seconds give you your answer using correct units. So secant slope, like part A, I'm looking for average velocity. Okay, first you have to ask yourself average velocity of, remember I said this word is important, of what? Average velocity of what? Average velocity of position, like a p of t. So I have to, in the formula, I have a p of t, which is p of 1 minus p of 2, and over 1 minus 2. So now I have to make sure that I get p of 1 and I get p of 2. So I'm going to do it over here. It's p of 1, plug in 1 in the original equation, which is t cube, like 1 cube minus 4 1 squared minus 3 1 plus 1. So the answer is going to be negative 5. Okay, now let's do p of 2. So plug in 2 in the original. So 2 cube minus 4 2 square minus 3 times 2 plus 1 will give me negative 13. Now all I have to do is plug in my secant slope. Negative 5 minus negative 13 over negative 1. They turn positive, so my negative 5 plus 13 equal negative 1. It's going to give me negative 8. That's actually positive 8 over negative 1, so it's going to be negative 1 feet per second. So that's my average velocity. Give your answer using correct units, which I did, and that's all they were asking for part A. Let's try part B. Here is B. On what intervals, which means all the x values of time, is the particle moving to the left? Left means it's supposed to go to the negative. And how do we know if the particle is moving left or right? We have to take a derivative, because velocity is going to give me a direction. And how do we know that? From the sign chart. So I have to take a derivative. I have to make it equal 0, because they're asking on what intervals. Make it equal 0, then we're going to make a sign chart. And from that critical points and then sign chart, that sign chart would decide where I'm going left, like where I'm going negative. So let's do the derivative. We have a function p of t. I'm going to write my function first. It's t cube minus 4t square minus 3t plus 1. So take a derivative of this, like a velocity. So I'm going to go p prime t equal 3t square minus 8t minus 3. Now I'm going to make this equal 0, because we need those critical points. Since I'm not using a calculator, otherwise I would graph this and I would graph this on different tabs and I will find the point of intersection. So I can do it. So what are the factors for 3t? It's 3 and 1, and 3t and 1t. What are the factors for this 3? It's 3 times 1. So let's figure it out. And I have both signs minus. It means 1 positive, 1 negative. So I have 1 positive and I have 1 negative. So I'm going to have a 3t plus 1. And let's make it t minus 3. I don't know if this is going to work, the setting. We just do it in our head, like 3 times t is square, 3t square. Then it's going to be negative 9t right? And then I have plus 1t, so negative 9 subtract 1 is going to give me negative 8. So that's how you are going to do in your head, like foiling, because that's how you know whether 3 is here or 1 is here or 3t is here or t is here, or that's how you decide. You just randomly pick, like I randomly pick these two, and I always pick these two. Then I do the foiling in my head. If it works, I'm getting back this question, then it's okay. Otherwise, we switch them around. So now make it 3t plus 1 equals 0 and t minus 3 equals 0. This one is t equal negative 1/3 and this is equal t3. Now we have to check which critical point we need because they said the t has to be greater or equal 0, right? Is greater than 0, which means it's positive, not negative. So the negative, we are not using it. We're going to only make a sign chart for 3. So let's make a sign chart for this 3. Pick something and plug it in p prime probably 0, that one p prime 4. If I plug in 0 here, I'm getting negative answer. If I plug in positive 4, like 4 times 4 is 16, 16 times 3, 8 times 4 is 32, and minus 3, I am getting positive here. So where I'm going left? I'm going left, the particle is moving to the left between 0 and 3. Like we start with 0, like we are talking about 0 greater or equal 3. So we start with 0, and also you can pick 1 here. It's still gonna give me negative. T equal negative 1/3, t equal 3. 3 is positive since my restrictions are t greater or equal 0, so it has to be greater or equal 0. So it's supposed to be positive answers. So this one doesn't work, but that one would work. Now I'm going to make a sign chart for this 3 starting with 0 because they said equal 0 or greater than 0. So pick something here for p prime 1. I plug in 1 here, I'm getting negative. You guys can try it. This is p prime 4, then it's going to give me positive. So I am going left, or the particle is going left between 0 and 3. So this is how we decide whether it's going left or right. So I'm going to say 0 and 3, the particle is moving left. Done. Part C. Part C said, using appropriate units, find the value of p prime 3, p double prime 3. Based on these values, describe the motion of the particle at t equal 3 seconds. Give a reason for your answer. So let's figure it out, appropriate units, and find p prime 3 and p double prime 3. Now, I already have a derivative of p prime 3, which was, the derivative is right here. So I'm going to use that. That's part C. P prime 3. I already have that derivative, so I don't have to take it again. So 3 and 3 squared minus 8, 3. Minus 3. So this is going to give me 3 times 3 is 9. 3 times 9 is 27. 24 minus 3. 24 subtract 3, or 24 or 3 is going to give me 27 minus 24, 25, 26, 27. So it's going to be 0. 0, the units are feet per second. That's p prime 3. Now let's figure it out, p double prime 3, which means I have to take a derivative of the function, which is that one. So we take a derivative, p double prime, or we can say that's an acceleration. Take a derivative. 3 times 2 is 6t minus 8. Plug in 3 there. 6 times 3 minus 8. 18 subtract 8 is going to give me 10. And that will be feet per second. Since that's acceleration, I'm doing it twice, so it's going to be seconds square. Now the question is asking, we figured out all of that. Now based on these values, describe the motion of the particle at t equal 3 seconds. Give a reason for your answer. So we know that since velocity, the v3, like a p prime 3, is equal 0, but acceleration at 3 is not equal 0, then it means at t equal 3, then it means at t equal 3, the particle is changing direction. Whenever your velocity is 0 and your acceleration is not 0, then it means the particle is changing position at that t equal 3. So this is something you guys have to remember it. When the velocity is 0 and acceleration is not 0, the particle is changing direction. So this part D for this question, what is the maximum velocity on the interval t equal 1 to t equal 3 seconds? Show analysis that leads to your conclusion. Maximum, minimum, the word maximum, minimum, at least, lowest, greatest, these are all the words when you see them, then it means this is absolute max they are talking about right now in this case. This is absolute maximum. But absolute maximum of what? Velocity. So we have to make the velocity equal 0. How? Absolute maximum method is derivative equals 0, critical points, and then you plug in critical points and endpoints in the original. Okay, now if they talk about, for example, if they talk about a maximum of a function, then you have to take a derivative of that function, and then you're going to make it equal 0, and the original is going to be that function. Since they are talking about maximum velocity, then maximum velocity means the velocity function, it's going to be y5. So we're going to take a derivative of the velocity, which derivative of a velocity, we're going to make it equal 0, and we get the critical point. We plug in that critical point and the endpoints in the original. So what is the original in this case? It's a velocity. This is acceleration. That's a velocity. So whatever maximum you have to pick that, like maximum of velocity, then pick this velocity, take a derivative, make it equal 0, critical points, which means that's going to be point of inflections in this case, because uh, take a derivative of a derivative means acceleration, double prime. So whatever word maximum, minimum they use, and you have a velocity maximum of a function, greatest point of the function or something like that, then you have to take a derivative of that. Maximum of whatever, you take a derivative of that whatever. In this case, we are taking derivative of a velocity because they said maximum velocity. So when we take a derivative of velocity, we make it equal 0, and we find point of inflection, in this case point of inflection, because that's a double prime. So my function is actually, I'm going to go and check my function, which is original. This is my original p of t. I'm going to write that original so I can take a second derivative of it. Plus 1, plus 1. So now you take a derivative of that. It's going to be a velocity. So 3t squared minus 8t minus 3. Now you are going to do v prime t, which means acceleration. We can also write this notation. That's 6t minus 8. Make this equal 0, and it's going to give me 6t equal 8, divide 6 both sides, and it's going to give me t equal 4 third. So that's my technical point of inflection, or you can say in this case a critical point of inflection. Then, since we are going to plug in the original is my velocity. That's my original. That's where I started doing maximum velocity. That's what it is. So my original is v of t. So I'm gonna plug in 4/3 in v function. I'm gonna plug in 1, which is my endpoint, and I'm gonna plug in v of 3. So when you plug in velocity of 4/3, it's going to give me that. This is the one I'm using, guys. This is the one I'm using. So it's going to be 3 4/3 square minus 8 4/3 minus 3. So I'm going to draw a line here so you don't mess up on that one. So this is going to give me equal some number, which is going to be, when you solve this, it's negative 25/3. When you plug in 1, it's going to be 3, 1 square minus 8, 1 minus 3, and it's going to give me negative 8. Then plug in 3, 3, 3 square minus 8, 3 minus 3 equal 0. And each one of them have feet per second. This one is also feet per second. This one is also feet per second. So these are my absolute maximum. So which one is maximum in this case? 0. So now we're gonna explain, give them a reason. The Since absolute maximum and minimum talk about extreme value theorem, so we're gonna say EVT, extreme value theorem, guarantees the maximum velocity. Every time when you're looking for absolute maximum and minimum, in the reasoning, you have to mention extreme value theorem because that's what belongs to them. It's maximum velocity on 1, 3 is 0 feet per second. Yeah. Now, part E said find the total distance that the particle moves on the interval 5, show and explain. So, like I said before, total distance, two different ways total. If the particle changes direction, then we use different formula. If the particle doesn't change direction, then we use a different formula for the distance. So in this case, particle is changing direction. Um, so when the particle changes direction, this was in part C, we figured it out that if the velocity, if the velocity was 0 at 3 and acceleration was not 0, then it means at t equal 3, the particle is changing direction. So that's what we figured it out in part C. According to that, it changes direction. Then we have to use a different formula. This is part D. I mean, not part D, I'm sorry, part E. This is part E. Total distance, we use a formula. It's going to be P of 1, that's the endpoint, minus P of 3 plus P of 3 minus P of 5. Okay, so my points are 1 and 5. So I just put them 1 and 5 at the end, and 3 is my t equal 3. That's what they're asking for the total distance. 3 is my critical point in that way. So when you plug in everything in the original position, when I plug in 1 in the original position, I got negative 5 minus, I plug in 3, I got negative 17 plus negative 17 minus, and I plug in 5, I got 11. So it will give me 12 plus 28, which is 40 feet. So the particle, now let's explain because they're asking for explanation, explain and show. So I already showed them, now I'm going to explain. The particle, since the particle changes direction at t equal 3, And that t, we picked t equal 3 because t equal 3 is between 1 and 5. The total distance is the total distance is the sum of the is the sum of the net distance distance net distance movement to the left and the net distance to the left and to the right. Yeah. So that's my explanation for that question. Now let's see this question. That's calculator permitted question. So we're gonna use a calculator on that one. This one side, a test plane flies in a straight line with positive velocity v of t in miles per minute at the time t, where if v is differentiable. If v is differentiable, then it is also continuous. I'm just going to write there because that's my v function. It is differentiable, then it has to be continuous. A function of t, selected values of v of t 0 to 40 are shown in the table. So this is what I got. Find the average acceleration. Average means a secant slope. Acceleration, so I'm looking for secant acceleration, like secant of velocity. So average acceleration means I'm going to formula should have a v of 5 and v of 20. And v 20 and 5 are included. I'm going to express units, and that would be over part A. So let's go to part A, 5 to 20. So this is actually 5 to 20 I'm talking about. So let's go part A. Part A said average acceleration equal v of 5 minus v of 20 over 5 minus 20, which is going to give me 9.2 minus 4.5 over negative 15. Plug it in the calculator, and your answer is 313 miles per minute squared. So that's my part A. Let's do part B. And since this is average acceleration, then over here in the formula, I have to have a one lower than acceleration, because acceleration we are looking for, so I have to have a v, right? This is double prime, that's the first derivative. Based on the values in the table, on what interval is the acceleration of the plane guaranteed? When I see the word, this is part B in green, when I see the word guaranteed, then it means that's one of the theorem we are talking about. What theorem? We will figure it out. To equal 0, acceleration of the plane is equal 0. So I'm saying acceleration of time is equal 0. There is only acceleration means double prime. So it means I'm talking about f double prime t equals 0. I'm talking about, this is the only one theorem that we have where the derivative is equal 0 or double prime equals 0. That's a Rolle's theorem. That's the Rolle's theorem says f prime x is equal 0. F prime c, I'm sorry. That's the Rolle's theorem. Fc equal k is intermediate value theorem. That's Rolle's. I just want to review your formulas for all the theorems. That's the Rolle's theorem, that's the intermediate value theorems, and mean value theorem said f prime c is equal f of a minus f of b, like tangent slope is equal secant slope. That's mean value theorem. So this is the only one formula where the derivative is equal 0. So in this case, it's asking double prime equals 0. So since it's already, we know it's a Rolle's theorem. According to Rolle's theorem, the conditions are the since it has to be continuous and differentiable. And we already said this is continuous and differentiable. Since v of t is differentiable and continuous, and f of a is supposed to be f of b. I mean, v of 0 is equal v of 15. Why would I say that? Because 0 and 0, this 0 and 15 is the only one that have the same y value, and that's what we that's the third condition for the Rolle's theorem, where f of a is supposed to be equal f of b. So in this case, since we are using v function, then it's v0 and v15. And I also have um, 25 and 24 and 30 and 2.4. I'm sorry, 25 and 2.4, 30 and 2.4. Again, my y values are the same, so I'm going to say v25 is also equal v30, and they are equal 2.4. So actually, I have two of those f of a equal f of b things. So it means, and in this question, if you pay attention, they never said find a c. So I'm not looking for c, like I'm not applying that formula, but I'm just going to explain it. So all the three conditions are here. Then Rolle's theorem Rolle's. I have to pick stuff from there. The Rolle's theorem guarantees a value on the intervals such that a of t is equal 0. That's what they say, a t equals 0. So it's done. Part C said, does the data represent velocity values of the plane moving away from its point of origin or returning to its point of origin? So we already know point of origin means, like, for example, this is my point of origin. So they said, is the data that I have up there, is that represent moving away from the origin, like I'm moving in this direction, like I'm increasing, or I'm away from the point of origin, or returning to its point of origin, all right? It's going in this direction, decreasing. So we're gonna see where it's going, the data in the table. I see data in the table. All the y values are actually is increasing. Look, 7.0, 9.2, 9.5, then 7.0, 4.5, 2.4, 2.4, 4.3, and then 7.3. And by the way, all of the velocity are positives. So it means if they're all positive, then it's increasing. If it's increasing, then it means it's moving away. Like I'm going in this direction, moving away, increasing. So let's try that and explain it. That's part C. Let's do in red part C. Part C said, since all values of v of t is greater than 0, because all of them are positive, like 7 positive, 9.2, 9.5, they're all positive y values. So it means greater than 0, the distance the plane is from its point of origin is increasing. So distance, that's what the question part C said. The velocity value of the plane moving away from its point of origin or returning to its point of origin. It's moving away because it's increasing. That's origin. And if it's greater than 0, then it's going in this direction, right? So it's increasing, it's moving away from the origin. So distance, so the distance the plane is from its point of origin, from its point of origin is increasing. Like this distance from the point of origin is increasing. So the plane is moving away. So the plane is moving away from origin. There. According to part D, the function f defined by f of d 6 plus cosine t over t plus 3 sine 7t over 40 is used to model the velocity of the plane. So technically, this f is the velocity function. Since they are asking for acceleration double prime, then I have to just take a derivative of this, and it's a calculator base. So you are going to do f prime t equal, not t, it's 20, I think that was, let me see, that was they're asking for 23. So f of f prime 23, you're going to plug this in the calculator, the function. You are going to plug in this function, and the x value is going to be 23, and then it will give you the answer when you plug it in the calculator. So negative 4 point, negative, not 4, negative 0.408 would be your answer, miles per minute squared. Now, they said, what does this value indicate about the velocity? This is the velocity actually, so that's what we got. I mean, this is the acceleration actually. F is the velocity. They said you have to read the question very carefully, because when most of the students, they see this is f of t, then they think that's the original. But you have to read the question. They said this thing is used to model the velocity of the plane. So this is actually the velocity. And then you have to find the acceleration. So you have to just get the f prime. Since f prime 23 is less than 0, which is negative, then velocity is decreasing. You know that that's acceleration actually. This is acceleration, right? If acceleration is less than 0, which means acceleration is decreasing, then the velocity is also decreasing at t equal 23 minutes. So that's the last part of the question, and we are done with this objective.